Hey everyone, what's going on? Chris Paris here, live from Brookdale University Hospital. Like I promised you, I saw your requests, and there were a lot of them, so actually that was cool. Thanks for sending them in. I saw your requests, and by far the two most common requests were acid base and diabetic ketoacidosis, interestingly enough. So we'll start with some, I'll do a quick acid base discussion again, guys. This is a 5-7 minute little mini talk. I can't go over all of acid base in this time, but just to give you guys a quick start and a quick understanding of some of the key points of acid base management. All right, acids and bases, ooh la la. All right, so where does the acid base story begin? Remember this equation from college chemistry? Remember this equation? Water plus carbon dioxide is interchangeable with carbonic acid. Remember this equation, right? Remember that equation? That's where all of acid base comes from. If you understand what I'm going to tell you right now, you'll understand 2/3 of acid base management. Life's a fantastic thing, right? Life in general. It bends the laws of physics, twists the laws of chemistry, manipulates everything, but never breaks them. Never breaks them. Just like my residents. They abuse me, they twist my patients, they temper it, they drive me crazy, but they don't break me. It's all love, right? Same thing with this. Just like this, right? I'm saying this because, of course, my chief resident's recording this right now. All right? So, the law of chemical equilibrium is what manages our acid base. What do I mean by that? If you remember from college chemistry, you could affect an equation by altering what? Substrates, right? You could alter substrates. By moving a substrate, adding or deducting a substrate from a side of an equation, you could push it to the other side. So for example, if you increase your CO2 concentration, you're going to push the equation which direction? This way, right? Follow, remember this? If you deduct a substrate, you could push an equation in the other direction. If I deduct, for example, bicarbonate, to put a different color, I'm going to push the equation this way, right? If you understand that, then you understand the basic premise of acid base. Because that's what our body does. Again, Ben's laws, twists them, doesn't break them. It alters substrates to maintain a pH of 7.4. Now, how does the body alter substrates? There's two major substrates the body alters, right? It controls two. One is bicarbonate via what? The lungs. One is bicarbonate via the lungs, and the other, carbon dioxide via the lungs, PCO2. Sorry guys, it's early in the morning and I didn't finish my coffee, okay? Carbon dioxide via the lungs, and bicarbonate, of course, which is what we are what? The renal system, right? Kidneys. Up or down? Up or down, right? You want more CO2? You decrease your respiratory rate. You want less CO2, you increase your respiratory rate. So respiratory rate is indirectly proportional to your PCO2 concentrations. That's very important to understand because that's how your body controls that. Now bicarbonate is a little different. Bicarbonate is altered by proximal tubule reabsorption rates. That takes more time. That takes much more time, obviously. So the quickest way to adjust this, of course, is respiratory rate. But renal function is the most stable, but it takes longer, hours to days. This could be altered in minutes, literally minutes. Cool? All right. So, whenever you're addressing an acid-base situation, you ask yourself, this is what I teach when I teach classes all over the world and all over the country and whatever the case may be, same class, all the time. There's 3 questions you have to ask yourself when you're dealing with an acid-base situation. Question number 1, are you dealing with an acidic situation or are you dealing with an alkalotic or a basic situation? Very simple. Easy. And how do we determine that? Based on the pH, right? If the pH, for all intents and purposes, is less than 7.35, you're dealing with an acid. If it's greater than 7.45, now I'm simplifying the range just to keep it clean, all right? Then it's alkalotic or basic. That's it. This is a simple yes or no question. So question 1, acid or base, right? So if I give you, for example, an ABG of a pH of 7.3 and a CO2 of 50, right, and a bicarbonate, let's just say, of 29. I'm just giving you a random situation, all right? Random situation, right? Question 1, what's the pH? 7.3. It's an acidosis. Done. You're already halfway finished. Already halfway done. You already know it's an acidosis. The second question you ask yourself, question 2, is are the lungs doing their job? Yes or no question. Yes or no. What do I mean by that? Based on this equation up here. In an acidic situation, what do you expect the lungs to do? Would you want them to hold on to CO2, or do you want them to blow it off? What do you think? Right? What do you think? If I'm already hyperglycemic, do I want more chocolate or do I want less chocolate? What do you think? Well, I probably want more chocolate. And if it's chocolate covered Doritos, even better, right? But that's a separate issue. That's my own personal bias. But the fact of the matter is, if you're in an acidic situation, right, you want the lungs to blow off CO2. You want to increase your respiratory rate. Now, normal CO2 is about 40. Our CO2 here is about 50. What do you think about that? That's inappropriate, right? The lungs are holding on to more CO2 than they're supposed to. So, short of it is, are the lungs doing their job? The answer is no, they're not. No. No, no, they're not. Third question you ask yourself at that point, are the kidneys doing their job? Similar approach. In an acidic situation, what do you expect your kidneys to do? What do you expect your proximal tubule to do? Hold on to bicarbonate or excrete more? What do you think? You expect it to hold on to more bicarbonate, right? To try to neutralize the acid. That's what you want your kidneys to do, okay? A normal bicarbonate is about 24, give or take. It's about 24. Our bicarbonate here is 29. So, are the kidneys doing their job? Yes, they are. We're not talking about compensations yet. We're going very simple right now, guys. We don't have time to do everything, right? The answer is yes, they are doing their job. They're holding on to more bicarbonate than they're supposed to. That's what you want. So the answer is yes, they are doing their job. Therefore, what is your diagnosis? It is a respiratory acidosis because the lungs are not doing their job and you're in an acidic state. Boom, there you go. All right, guys? That's a really quick description and way to break down acid base. Obviously, there's much more to this. You have compensations, you have, and so on and so forth. We just don't have time. If you want to see me full time, you have to come to a lecture. Otherwise, I can't. I love you guys, but I can't. All right? So, be good. Love you guys. Real quick acid base, and a little later on, I'll put up some diabetic ketoacidosis points. Take care.